Okay, connection should be streaming. We're double broadcasting. It is February 8th. This is CS-030. Going to just YouTube broadcast. Going to just YouTube broadcast. Going to just Inception first. YouTube broadcast. Going to just Inception first. YouTube broadcast. Going to just All right, good morning, everyone. Rough start for Professor Patterson. Let's see. All right, broadcasting in game, or broadcasting YouTube, not in game. Make sure that's clear to everyone in the region. And let's see, so today we are, let's look at our calendar real quick. Let's screenshot that, stand by, find my calendar. Do not see calendar, we'll make a new one. Okay, here's a calendar. Good, and we're looking at this class. All right. Today is Monday, February 8th. We're in week 5 of the semester. We are wrapping up the discussion of last week we wrapped up the discussion of chapter 4. This week we're going to begin the discussion of chapter 5. Chapter 4 was about fundamental data types, and chapter 5 is about decisions and if statements. This Friday you have an exam. The exam will be in class. It'll be during the class period. It will be through Canvas. All right, so let me just make sure. Looking in game. Okay, so can everyone just respond to me? When is your exam? By responding in chat. Make sure everything's going okay. Great. Okay, super. The format of the exam will be 60% multiple choice, drawn from the work that we've done on Technies before, and it'll be about 40%, I mean, these are rough percentages, some kind of programming, short answer kind of stuff. It will be open book, open note, open internet, just not open communication. And it will cover through chapter 4. It will include chapter 4. It will not include chapter 5. It'll be chapter 1, 2, 3, and 4. Okay. There is no programming assignment for chapter 4. On Slack over the weekend, I distributed what the programming assignment sometimes is for chapter 4 when we do it, but that is entirely optional. Some students had asked to have access to that for practice. So you can practice if you'd like, but for chapter 4, there's no programming assignment. For chapter 4, there is a Technie though, and that's due Wednesday, and that's indicated on the Canvas calendar right now and in your to-do list. Okay, questions or comments about scheduling? Okay, let's just real quick make sure you rebake your avatars. I forgot to run through the checklist with you, although I did it myself. And make sure your world is set to midday. Okay. All right, I am looking around to try and find my plan for today. There it is. Okay, great. All right, let's open with a word of prayer, and then what we're going to do is we're going to try and connect on JMonkeyUnit, and we're going to try and do a little refactoring of a box that draws in the JMonkeyUnit demo, both as inspiration and just give you something that you can play around with if you'd like. I see that Josh asks, will there be practice questions posted to Canvas for the test? Yes, I can do that. It's best if you don't retake previous Techni assignments, because if you retake previous Techni assignments and Canvas shouldn't be allowing you to do that, but I often don't get the settings exactly right. And if you do that, we have to do a correction where we go back to your previous Technis and adjust your grade, because if you take it again, you'll get a 0 because it's considered late. And so instead, what I like to do is set up practice exam for you for practice exam questions, and that will be under the milestone item in the Canvas. So under milestone 1, you'll see a practice exam quiz when I can get that up and going. All right, I'd like to open with a prayer today from Metropolitan Philaret of Moscow. I don't know if you're familiar with it. It shows up from time to time in at Westmont, and I will read it for us. If you join me. O Lord, grant me to greet the coming day in peace. Help me in all things to rely upon your holy will. In every hour of the day, reveal your will to me. Bless my dealings with all who surround me. Teach me to treat all that comes to me throughout the day with peace of soul and with firm conviction that your will governs all. In all my deeds and words, guide my thoughts and feelings. In unforeseen events, let me not forget that all are redeemed by you. Teach me to act firmly and wisely without embittering and embarrassing others. Give me strength to bear the fatigue of the coming day with all that it shall bring, and direct my will. Teach me to pray, and you yourself pray in me, to the glory of the Father, and of the Son, and of the Holy Spirit, now and ever, and unto ages of ages. Amen. All right, thank you. Now what I'd like to do is switch to Eclipse, and in Eclipse I'm going to attempt to share the JMonkey Engine project that we'd worked with before. We'll do this in a couple rounds. I've been trying to share it with a few of you with moderate success. A couple things we learned is that if you're on a slow bandwidth connection, this doesn't work very well. So we'll try and add you one at a time. This is the same JMonkey Engine demo as last time, so your synchronization will speed up if instead of creating a new project, you write over the previous project that you downloaded. That way you won't have to re-download all the material that you've previously downloaded. So here we go. All right, Ben A, there you go. Carson, Ethan V, Faith, Landon, oh, stand by. Okay, try again. Landon, don't edit anything, please, until I have a chance to switch you to read only so that you can't. Trent, Thomas, Adeline. All right, we'll let those go for a sec. All right, those seem to be going pretty well, and shockingly. All right. All right, so some of you look like you're on pretty slow connections because it looks like synchronizing is going to take like 30 minutes. And so we're not going to wait for that. So what I'm going to do is I'm going to go through a pass here where I set people to read only, and then we'll see how we're standing in a moment. All right, so Adeline, we're going to try and switch you to read only. Ben, we're going to try and switch you to read only. Carson, we're going to switch you to read only. So far, so good. 3 for 3, that's good. Ethan Vaughn, switch you to read only. Good. Faith, switch you to read only. So far, so good. Josh, going to switch you to read only. Glitching. That suggests to me you're having... No, worked. Okay. Landon, read only. Good. Matthew, you're already read only. Morgan, switching you to read only. Trent, switching you to read only. Thomas, switching you to read only. I'll do one more set of invitations for folks who have shown up since last time. So Ben, here's a new invitation. Ethan B, here's a new invitation. Frank, here's a new invitation. And Sam, here's a new invitation. Okay, let me go through and update read only for that second round, and then we'll proceed. Well, for whatever reason, grace of God, I suppose, we're connecting pretty well today. Okay. All right, let's go ahead and move forward then with this as our current environment. Some of you are still synchronizing, but we'll proceed anyway. What I'd like to do is I would like to run this code for starters. And what you should know about the way that this code is structured is that the way you run it is by running the environment class under the SRC folder. And that environment class will launch has a main method in it and will launch a program. It'll launch it in this JMonkey engine environment. And we can go ahead and I'll go ahead and pull up environment and show you what's happening a little bit here. So we go down to main and environment, and this is the main class. And you can see we do a couple things here. We haven't gone over what the syntax means yet, but we're creating an array, an empty array with a variable named drawables. And then what we're doing is we're creating a new object of type myWorld, which is what our code comes from, and we're adding that to the list of things to draw. We're just doing that directly in a chaining event here. Then we're going to create an environment object. This is something that's provided by JMonkey engine. And when we create it, the constructor takes the list of all things that should be drawn. Then we go ahead and we start the application. And so line 153 here is where the program actually runs. And so if we right click on environment and we do run, here I'll do it in games or in screen so you can see it. Right click on main and we run it as a Java application. It'll bring up the JMonkey engine window. Boo. Waiting for it. There it is. I'm going to shrink the size of the screen that it draws from just so it shows up well in broadcast. There we go. Makes a small little window, and you can see that we put a texture of Dodger on it. And using the mouse and using the mouse button and zoom in and zoom out, you can rotate around and do different things there. So that's pretty good. So that's the nature of the program. Now that cube there and the environment that it's in are all chosen by me, and they're chosen by me in the My World class. And let's take a look at that to see exactly where that's coming from. So switching over to the My World class, when we look at that, we can see that this isn't something that you know by default, but the way the environment works is that when you create a world, when you create a class that you want to have something that your class holds all the things that should be drawn, that you want drawn. And so in order to do that, your class has to extend from another class, means it needs to inherit from a class called drawable. Drawable has a bunch of methods in it that we don't need to duplicate, but which are leveraged by JMonkey engine to draw the things that you want to draw. To specify new things that you'd like to draw to the environment, you create a method in your class called draw, and it returns a type, another class called spatial, which is provided for us by JMonkey engine. And then you can see that the code that we do here ends up creating that box. We create a node class. A node class is a specialized type of spatial. So node inherits from spatial. And so down here, when we return node, you might say to yourself, wait, you're returning a variable that's of type node class, but your class says you should be returning something of type spatial. Well, let's see if we can get it when we hover on it. Well, the node, I can't demonstrate this to you easily, but the node class is a child of the spatial class. So you can return any child of a spatial class from a method that requires a spatial class. So we're going to create a new node. And then we do some kind of specialized stuff down here. We create a new material, and this material is going to talk about what the outside of the box is going to look like. But we create a material. we create a texture, and you can see that in this texture process of creating a texture, I create something called a texture key. I don't know all the details of all of these classes. They're provided by JMonkeyEngine, and I worked through some tutorials in order to be able to use it. But you can see that I'm referencing a file here, assets/dodger.jpg. And if you look over in the resources on the left, you can see that there's a folder called assets, and in that folder is a bunch of different image assets and font assets that I'm using, one of which is dodger.jpg. That's where I got the picture from. So when I specify assets/dodger.jpg, I'm picking the file that's in my project here called dodger.jpg, and I'm going to put these things together to put it on the outside of my box. All right, so this key.generate MIPS is a graphic engine setting to set the way in which our texture is generated. Then we're going to we're going to load a texture based on the different objects that we've created before. Again, this is just boilerplate. It's not something I know very well. We're going to define some particular ways in which the texture is treated when it gets to the end of the size. Like, do you want to stretch the texture out over the edge of your object, or do you want to keep the aspect ratio the same, etc. We're going to go ahead and give it a particular, we're going to apply the texture to this box material. And at the end of this whole code right here, what we've done is we've created a box material, which is a variable that we declared that we're going to use in the next piece. Now in the next piece, we create the box. The way we create this box is we call constructor. If I hover over the constructor, you can see that there's an X, a Y, and a Z position that we give it. We're giving it a coordinate in the world. And if you look at the documentation for it, you can see the box has a center of 0, 0, 0 and extends in the out from the center, which doesn't make sense, but it's a typo in the JDoc, extends out from the center by the given amount in each direction. So for example, a box with extent of 0.5 would be the unit cube because it goes out 0.5 and back 0.5 in each direction. So here we go. We define a unit cube. We use a literal of 1.0. We put the F there to force it to be a floating point, a float rather than a double, because box was developed in a way that it requires floats, not doubles. So we explicitly have to create a float in order to make sure that that's not treated as a double. We say scale the texture coordinates by a particular amount. So we say we want the texture scaled evenly in the X and Y direction, and we do that by using this particular structure. We create a new geometry for the box, give it a name. We set the material of the box to what we had before. We give the box a way in which the shadows are handled in game, and this box is going to cast and receive shadows on it. Then we take the node, which is the spatial element of the environment, the data structure for the environment. We're going to put the box that we made on it, and then we're going to translate it, and we're going to translate it 0, 0, 0 for the time being. So that creates our box. And to just demonstrate what that's doing, let's go ahead and give our box a different size. So let's make it, instead of being 1 in the Z direction, let's make it 10 in the Z direction. And then let's try and run that again. Go back to environment, and we're going to run it as a Java application. We'll save everything first. Launch JMonkeyEngine. And now we get a box that's been stretched out in the Z direction. It's 10 now instead of 1. You can see that there's some problems with the way that the texture is applied, because now the texture doesn't look good if it's stretched out that far. But if you look at the end of the box is still okay. You can't kind of dips around the bottom. You can't really see it. So all those different settings enable us to do different things like stretch this image in ways that we want to create the effect that we want. But what I want to do for now is I just want to show you how to refactor this into a different kind of architecture so that it works a little bit better for us. Because a lot of this code is pretty technical, and I would like to encapsulate it and abstract it in a way that I don't really have to think so much about all these details. And so what I'm going to do is the method draw has to be public because another class has to use it from JMonkeyEngine, but I can create a private method in my world class, and I'm going to go ahead and do that. And I'm going to do this, and what this is going to do is it's going to create a box for me, and it's going to take all of the work that I have done, and it's going to wrap it up in this private method, and we're going to abstract it, and we're going to encapsulate it, and we're going to use it so that we don't have to think about all of these different steps that are required to make a box if what we want to do is actually just build a box. So the way I'm going to use it is I'm going to take this code, I'm going to temporarily cut it out, and I'm just going to drop it up here outside of I'm just going to drop it here just as a place. It doesn't make any sense to put it there because it's not in a method, but I'm just putting it there for the text file to hold it for a second. Because what I'm going to want to do here is I'm going to still have a node, and instead of doing that, I'm going to call my box method, which I haven't implemented yet. I'm going to say make box. And then I'm going to, let's see, node.add child. How do I do that? Let's see. Let me think. Something's missing here. Node.child. There it is, attach child. Okay. I'm going to attach the child box1, and I'm going to return it like that. So this is what I want. I want my draw method to be very clean and concise. I want to create a node. I want to call my method called makeBox. I want to return a box. I want to attach it to my environment, and I want to return it. I don't want to think about all the details. I just want to encapsulate my details in a method called makeBox. So to do that, I need to have my makeBox method, which I've stubbed out there. And now I'm going to take the code that I put as a placeholder, and I'm going to drop it in here, and I'm going to adjust it so that it works as a refactored method. All right, so I make a new node within makeBox to hold it. I'm going to go through all the process here that I did before, and I'm going to return that node that I made, which is going to be the box. Eclipse cleans up my errors. I have no errors here at all. And so now basically what I've done is taken all that work from before, rolled it into a makeBox method, put that up here, and now I'm calling it. So now if I run my program, everything should be the same. All right, pretty good. Looks the same. Now what I want to do is I want to parameterize my method. I want to say, okay, well, make box is great, but what I would like to be able to do is use it in different ways so that I'm not also always making the same box. So let's start by adjusting the size. So what I'm going to do is I'm going to change the way that make box is called so that it takes the size of the box that I want to have. So let's have it, for starting purposes, be a unit cube. My make box is, the Eclipse is giving me an error because make box doesn't take those parameters. That's because I haven't changed it yet. So I'm going to go up here and I'm going to add 3 parameters, which are going to be the size, and we'll say this is going to be the width, the length, except that I got to get the type right. It's going to be the float. It's going to be the width, length, and height. And I'm going to go ahead now to JavaDoc for myself to use. It's a private class. It's not part of the public interface, but we'll just add this here for good practice. So this class makes a box with the parameters shown and returns it. Straightforward. Width, length, and height doesn't really need any explanation. That's pretty clear. But we're not actually using width, length, and height in here at all. Instead, we have it hard-coded right here. So let's go ahead and make it so it's not hard-coded. Width, length, and height. All right, you can see I'm dividing it by 2. That's a little unclear why that might be, but that's because I'm changing the sense in which these values are being used. Box says that when you pass it an x, let's see, the box has a center, yeah. So when you create box, it says the box has a center of 0, 0, and extends out from the center by the given amount in each direction. So for example, the box with 0.5 would be the unit cube. So, you got to read what it does, because X, Y, Z sounds like it's a position, but actually it's a size when you call box. And you assume that if it's a size, if you say it's going to be 1, then it's going to be 1 on a side. But if you actually pass it with x equals 1, based on the documentation and the behavior that we see, if you pass it with x equals 1, it's actually going to be a length of 2. And I would like to correct that with my make box method interface so that the width really is the width of the box that you get. So to do that and to make box work, I have to translate box by translate width, length, and height by divided by 2 in order for it to work correctly. All right, so now if I come back down here and I call my make box with 1.0, 1.0, 1.0, I should get a unit cube with Dodger kind of looking normal on it. So let's run that, make sure everything's working as we expect. Okay, pretty good. It doesn't look like it's a unit cube, and that's because half of the cube is extending underneath the grass. And you can see that if you rotate it around. Half the cube is underneath the grass, and half is above. The grass, yeah, there you go. So if you kind of mess around with the perspective, you can see it is actually a unit cube, but the ground is sort of messing up how much you can see. All right, so we've abstracted away our make box so that we can now make multiple boxes, and we can do it with different sizes. Let's additionally position this box in a particular location. So right now, if we want to give it a length, width, and height, we know how to do that. Why don't we change the interface, change the public interface of make box so that the first thing we pass in is actually the X, the Y, and the Z position. And we'll go ahead and add this here. We'll say X, and I'm just going to say YZ, the center of the box. I'm not sure JavaDoc will format that correctly, but we'll just leave it like that for now. All right, so we come down here, we have make box takes XYZ now, width, length, and height. Width, length, and height, they're still fine, but we need to adjust the translation. So we want to translate it by X, Y, and Z in order to move it around. That should take care of that instead of hard coding it to 0. So if we come down here and we add our additional parameters in here, let's put it at, let's say, 2.0 on the x-axis and 0 on the y-axis, and let's make it at 0.5 on the z-axis. So hopefully if we did that correctly, the box should look like it's sitting on the grass, but not on the center point. Let's go ahead and run that. All right, looks pretty good. It certainly is not on, it's off center, that's for sure. So that's good. So maybe we actually got our X, Y, and Z off because I would like Z, maybe Y. I'm not sure how the X, Y, and Z coordinates are currently mapped. Maybe Z isn't up and down. Maybe it's Y that's up and down. So let's see if we can fix that because it didn't actually pop up above the grass, and I'd like it to do that. Let's see if that changes it. There we go. All right, so that's much better. So it looks like the y-axis is the one that's coming out of the grass, and x and z are the width and the length of the land that we've got there. So good. We've got the ability to make a box, and we've got the ability to move its location around. Now let's demonstrate the value of encapsulating that method, that idea, encapsulating the idea of making a box. And what we can do is we can leverage that by now creating multiple boxes. And it's a lot easier to create multiple boxes because we don't have to cut and paste all that code above. We can just cut and paste the make box code. And we don't want the same box over and over again. So let's put one box at 2, let's put another one at -2, and let's put one at the origin, but let's have it hovering in the sky at 2. So this should look like kind of a triangle of boxes, one at 2, one at -2, and one at 0, 0, but 2 in the sky. And they're all got the same size. Here's a great reason why you pay attention to Eclipse warnings. So I was thinking about how I want them all to be the same size or not. So I was focusing on the 1.0. And I look over here and Eclipse says to me, hey, you're never using box 2. You must have made a mistake. You should be aware of that because it looks like a mistake to me. And I say, no, I'm totally using box 2. I'm using it to make a second box. But the place where I think I'm using it is here. And I'm not actually attaching box 2. What I'm doing is attaching 3 copies of box 1. One here, one here, one here. And that would give me a scene that has 3 overlapping versions of box 1. The Eclipse warning gave me a clue that something was wrong. So I'm going to change that to 2, which is what I hoped for. And I'm going to change that to 3, and then my warnings go away because that's what I actually intended to do. Let's go ahead and run that. Great, now we have this triangle of boxes in the air, positioned as we indicated, all of them with the same size and all of them with the same texture on it. We can zoom in, and there's limited ways in which we can move the camera in this example, but it's a nice little setup for that. Let's do two more things. Let's for the next one, let's adjust the size of these blocks. So let's make the one that's hovering over the center down here, let's make it a little bit smaller. So instead of being 111, let's make it 0.5 on a side. And let's make these not be cube. Let's make it 2 in the x direction and 2 in the z direction. Let's run that just to demonstrate that we're actually making different cubes that are not cubes anymore. All right, so now you can see we have a little box hovering in the middle, and we've got two boxes that extend out to the side. They're double the length that they were on one particular axis, but they remain 1 and 1 on the other two axes. You can see how cast and receive shadows is used, that particular setting that's buried in make box, because you can see that each of the boxes cast a shadow, and you can see that as the shadow is on top of the two boxes below, the shadow from the top box falls on top of it. And we could change that behavior if we wanted to. We could have it such that the boxes didn't cast shadows or didn't show shadows. The ability to cast and receive shadows increases the complexity of what the software has to do in order to correct for that. All right, so the last thing that I'd like to do, I'd like to refactor out the texture. So we know that these are all getting a picture of Dodger, and let's come up here and let's change it so that the last thing that we have is we have a new texture. It's going to be string because the way we're going to specify it is a file path. We're going to say that it is a file path to the box texture. Return the box. All right, so what we did is we threw that on the end. We made it a string, and the word texture is what we're using for the variable name. Down here is where we use it, so we'll just replace this with texture. And we know that what we need to do now is down here, because we've added a new parameter to make box, we're not going to compile cleanly down here. We need to know what we're going to add as our texture. And so we're going to, oops, there we go. So to correctly call it, we need to do something like that. We need to put the texture at the end that we want. These on line 54 and 57, we have errors because our method requires that and we're not providing it. We don't actually have, what else do we have for textures down here? We have something called box.jpg. What does that look like? Okay, so that's sort of some sort of cardboard texture. Well, that's good. Let's add a cardboard texture on one of them. So assets/box.jpg. Good. And what's map? Map's probably the grass. Yeah, map's the grass. So let's, since it's there and I don't want to take a lot of time loading a new texture, let's go ahead and put that in. So one of our boxes will have Dodger, one will have a cardboard texture, and one will have the same texture as the ground does. If I get my everything lined up. Everything compile, save it, and let's run it out. There we go. So you can see we've got a grass textured box at the top, a cardboard box, and the Dodger box as before. So that's what I want to show you. I want to kind of inspire you a little bit for things that you can do and the way in which this work that we're doing ends up getting used in practice. Let's just reiterate what happened there. We had a method for making a box. We wanted to create a private method that enabled us to make boxes rapidly. And so we went ahead and we encapsulated our code. We refactored it into another method that does the same work and returns the result that we previously used. We were then able to use that method repeatedly as a private method meaning it can only be called from other methods within the class. We called it repeatedly, received the result in 3 different cases, added it to the data structure that is drawn, and then we're able to draw a lot of boxes. So that's what I wanted to show you for the JMonkey engine example. It's an example of private and public methods and passing some parameters. It's an example of literals. We had to use explicit floating point literals. We had to use string literals as well. All right, let me provide an opportunity to ask any questions that you have about refactoring or about literals or about strings at this point. I guess anything you've got. All right. If something occurs to you, feel free to ask it and we'll tackle that. Some of you are still synchronizing the project. What we found is that if you're able to be on campus to synchronize the project, it seems to work much quicker. And so what you can do is you can connect with me sometime during office hours if you want, and we can finish synchronizing the file. I'll attach the project. I'll attach the project to our Canvas today so that you have access to it. But I'll be honest, it's a little bit difficult to import an entire project into Eclipse from a zip file. I'll provide it. It can be done, but it's complicated because of all the different ways in which the project is linked together with source files, libraries, assets, and all that jazz. Okay, so the next thing what I want to do is I want to shift gears to talking about Chapter 5. Chapter 5 is about decision making and if statements. It's very similar to the way in which we had if statements when we were working with Python, and so I don't expect it to be of great difficulty. And I think I would like to work with this with code again. And in order to do that, I'm going to break this current session and I'm going to share a new session with us that we can look at examples of the code. So, okay, here we go. I'm going to stop sharing the existing session. Okay, there we go. The other thing that you can do, by the way, is if one of you did get a complete copy of the JMonkey code and you do the action of being the host of sharing a Saros project, you can invite a friend, perhaps one of the people who wasn't able to get the whole code is a friend that you want to share it with. You can host the project and you can share the project with your friend, and your friend can then overwrite the existing project with your copy. So this is something where you can sort of pass the code around as long as you're careful about who's hosting and who's client, and then also careful about overwriting projects along the way. Okay, so today's is we've got class 12 ready to go. I'm going to go ahead and share this with you. It's much shorter and it's a much smaller package, so I imagine that it's going to share very rapidly. We'll see if that's in fact true. Here it comes. Yeah, also because we are starting a new chapter, chapter 5, and while you all are synchronizing, we need to get a Dodger update. Dodger had a good weekend. He was not feeling super at the beginning of the weekend, and by the end of the weekend, he was doing great. Like he was sick or something, dogs eating grass kind of sick. Not a lot, but. So we have another breakfast shot. This is the pair of eyes carefully looking around the edge of the table, not to offend, merely to announce presence should I want to share anything. That's Breakfast Dodger. Dodger joins us for church. We do church at home, and so one of the things I like to do is make bread for communion, and then Dodger likes to sit on the pillow with us during church, but we have to sort of aggressively block him from eating the communion bread. Crumbs from the table, all that jazz. This is him waiting for communion, suffering through worship. And then I don't know, this is just a close up. He's got a big wart on his nose. It grosses us out, but it's endearing. All right, let's see how we're doing. Looks like a lot of you have been able to connect. Let me go through and set it to read only for us. Let me open up our project. Let me go ahead and make a class for us so that we know what we're working with here. All right, making a class with a main method. You should see that show up in a second. Let me make sure we're broadcasting okay. All right. There we go. Going through and setting to read only. How'd that work? Okay, Addie setting to read only. Ben to read only. Ben D. Ben A. Carson, Ethan, Ethan B, Ethan V, Ethan B, Faith, Frank, Matthew, Dee Dee, Morgan, and Sam. Okay, great. So this chapter is about if statements and the logic associated with if statements. And so here's an example of a class from our textbook called Elevator Simulator. And what we would like to do is we would like to create a simulator of an elevator that takes input from the user and uses that input to send the elevator to a particular floor. Now, this is like many buildings in the United States, it does not have a named 13th floor. Of course, physically it has a 13th floor, but it names it the 14th floor so as not to make people who are superstitious afraid of staying on the 13th floor. This is a real thing. If you look on elevators in a hotel or tall building that you go to and you pay attention, you may notice that the 13 is missing. Not in all buildings, of course, but in many of them, and it's kind of thing that you don't even notice unless someone points it out to you. So let's see if we can work through what that's going to look like. Look through first accepting input from a user. It's mentioned in the book, and what we want to do is give an example of this. So we're going to create something called a scanner class, and that is provided by the Java environment. We're going to do that by creating a new scanner by calling the constructor there. We get some errors from Eclipse. Let's hover and see what it says. It says that cannot be resolved to a type. Doesn't know that type. Well, we know that's a real type. So a common way to fix that would be to include that through an import statement. So I'm going to look at my command 1 for me, maybe control 1 on your computer, and it has a bunch of options for what to import. Now, if you notice there's 5 different options for import statements that Eclipse will add. That's because there's more than one scanner class that Eclipse knows about. Many different packages provide something called a scanner. And so if you just take any of them, it's not going to work because the scanners in different packages have different interfaces. You have to make sure you're getting the scanner that you intend to get. It's like saying, I don't know, what would that be? That would be like saying, I want a soda. And someone's like, okay, here's a soda. And you could get a Coke, or you could get a Sprite, or you could get a Diet Dr. Pepsi, berries, and cream. And they're very different depending on what you get. And so we want to make sure we get the right one. And so the standard version that you get comes from the java.util package. Now, you may not know that offhand, but one thing that you note is that by being careful about the package name, you can see that this is a package name that belongs to java.something. And if it starts with Java, that means it's coming from the libraries that are formally associated with Java. You'll see that the other ones come from Sun Corporation, something from JDK, internal parser, something from Sun Tools. They're probably fine for their context, but that's not what we want. So I'm going to hit return on the first one, and you'll see that line 3 gets added for me automatically, and you'll see that one of my errors goes away. My next error says that the constructor scanner is undefined. That's the 4th error at the bottom. And so any one of these things are possible errors, but Eclipse doesn't know exactly what kind of error you're working with. So one thing you have to know about the way that you call scanner is in the constructor, you have to tell it what it's scanning from. The scanner works like a grocery store checkout scanner, where the checkout person will take your object and will pass it in front of the laser, and the laser will read the barcode, and then it'll enter into the inventory, and everything else will go on. That's great. And what scanner does is it reads system.in as if that is a conveyor belt, and it looks for data coming in off of that. System.in is the analog to system.out. It is the console. And so when we scan system.in, we're going to be scanning the console for input coming from the user. So what we would like to do is we would like to prompt the user for some particular input we'd like. And so we'll say system.out.println, we'll pretend like we're the elevator, and we'll say which floor. question mark, give it a space, and this is going to, if we use println, it's going to go ahead and go to the next line in our console, but I actually want to stay on the same line. So I'm just going to use print instead. The next thing that I'm going to do is I'm going to try and read in the floor that the user has asked for. And so now I need to use the scanner, and I'll call it requested floor. And I am going to set that equal to, so I've used a primitive type int, I've declared a variable requested floor, and I'm going to get that from my scanner. And so I'm going to say in, which is my variable name, and I'm going to use a method that says next int, which says, scanner, you should expect an integer next on the conveyor belt, and when you read it, I want you to take those characters that you read in your console, I want you to convert it to an integer, and I want you to store it in my variable for me. If the user doesn't type in an integer, we're going to get an error. So we can't really handle that yet, but for the time being, let's just prompt the user for the right thing. It's a little awkward, but we'll go ahead and just prompt them like that so that at least have a hope of knowing what we're looking for. All right, now what we need to do is we need to set up the actual floor that we want the elevator to go to. So we're going to declare an integer variable called actual floor. And the difference is that if someone requests to go to floor 14, that's like they're pressing the button. And we want them, if they type in 14, to actually go to 13. So we're going to use the if statement in order to do that. And we're going to say if requested floor is greater than 13, then we're going to say actual floor equals requested floor minus 1. All right, a lot of things just happened there. I introduced the idea of an if statement. So the if statement structure in Java starts with an if, shocking, and it requires a condition. The condition is bounded by parentheses. You always, in Java, you have to put parentheses in order for the if statement to compile correctly. You'll see the Eclipse is giving me the red X of doom, which means it can't even parse it. Can't even give me suggestions because it doesn't have any idea what I'm doing. So if you put parentheses around it, your conditional always has parentheses around it. It can have multiple parentheses embedded, but it's got to have one outer set of parentheses. So when we were working in Python, you might have seen me doing this in my conditionals in Python because I'm sort of my memory muscle or mental memory muscle from programming in Java. It's required. In Java, in order to indicate that we have a compound statement, we don't use a colon. Recall if we did this in Python, we would have said something like, if requested floor is greater than 13, then we would have put a colon and we would have indented. That would have been Python. In Java, we indicate a compound statement with curly brackets. So anything within these curly brackets are going to be what happens during the, if it's true. If we decide not to put curly brackets in, the if statement can only run one line afterwards. All right, so curly brackets enable us to run one or more lines as part of the true condition. No curly brackets means we're only running one line. If we add another line, it's not going to be part of the if statement. Now, because Java doesn't care about indentation, the indentation here is just for us. And this would be perfectly valid code if we wanted to do this. So let's just demonstrate this. Let's go ahead and finish out our code here by saying system.out.println, and I'm going to type out the elevator is really going to, and I'm going to use, let's use printf. Let's use a printf statement to demonstrate that. It's really going to, and we're going to put a %d in there, and to fill in that %d, we're going to add another parameter, and it's going to be actual floor. And because printf doesn't give us new line characters, we'll force a new line character at the end of that. All right, so the %d is a format token that's going to be replaced by actual floor. Then we have a new line character. I'm getting an error from Eclipse because why? Let's look. It says the local variable actual floor may not have been initialized. What Eclipse is doing is it's doing a favor for me. It's saying, hey, there's a way that you could have gotten to this code such that actual floor didn't actually get a value. So let's hold off on answering that, and let's just finish out our class for a second. Got two curly brackets to end our method and to end our class. Then let's, what happened here? It's not understanding that. What did I do wrong? Let's see, I've got an error because line 22, it doesn't understand that that's matching that semicolon. That looks like good Java to me. Let me save the file. All right, I've got some syntax error here because Eclipse doesn't think that I ended my file cleanly. There's a syntax error here. I don't know what that syntax error is. Is there another one down here? Oh, there we go. Okay, I had put extra curly brackets at the bottom. They were scrolled off the bottom of the screen, so I didn't see them. And so Eclipse was saying, hey, this doesn't look right. It's not compiling correctly. And so I had to delete some lines in order to reveal those additional curly brackets below. If I delete these curly brackets, it should compile. Okay, great. I do have some warnings and errors, though. All right, my first one is that there's a way that I could get to actual floor such that actual floor doesn't get initialized. Well, how does that happen? That's a path through this code where actual floor isn't initialized. We can get to line 13 and we can declare this variable. That doesn't initialize it, just declares that we're going to use it. We come to line 15, and if requested floor is greater than 13, then actual floor gets a value. But if requested floor is not greater than 13, then we end up in this situation where we jump over line 16 and we get to line 19 without actual floor ever getting a value. And so I'm getting an error. Eclipse is saying, hey, you've made a logical mistake, and it's a pretty sophisticated mistake that Eclipse is picking up. So in order to do this, I could make two changes. I could either put an else statement on my if. In my else statement, I could make actual floor have a value, or I could initialize it on line 13. So that you can see how an else statement works, let's go ahead and add an else statement. Else has to be paired with the if. It comes after the curly brackets if we want. Like the if statement, if we have no curly brackets, we can execute one line of code after the else statement. Perhaps we'll say actual floor equals requested floor in this case. Now, no matter what we do, actual floor is going to get a value because it's either going to be true or it's going to be false, in which case actual floor will receive a value in both cases, and my error on line 21 goes away. Great. I'm getting a warning on my scanner, and it says resource leak. In is never closed. All right, so there's a bunch of different things I'm going to show you here now. All right, for starters, code hygiene. So if you ever create a scanner, you always want to close your scanner before your program is done. This is not going to do anything particularly bad to your code if you don't do this, but what will happen is there are other situations where you have resources like this where you do need to close it in order for something bad to not happen. An example of that is a database connection. If you create a connection to a database and you don't close it, it may be that some of the changes that you make to your database don't actually stick in your database because they're being buffered. So it's good practice whenever Eclipse gives you a warning that you did not close a resource that needs to be closed, that you close it at the end. So this is option one. Let me give you a different option. Let me see, how can I communicate this? All right, so I don't know, you're just gonna need to pay attention. So option one is you create a scanner in a way that you know, and you close it. You're not gonna see this in practice. This isn't the professional way to do it. The professional way to do it is instead, let me comment it out, to use a try catch block, which is an exception catching mechanism. And what we're going to do is we'll say try, and we'll put in parentheses what it is we want to set equal, what it is we want to initialize. We create curly brackets at the end. Again, we indent just for our purposes as a programmer, not because Java requires it, because I want to be able to see what's going on. And then we don't have to have a close. And this is what professional programmers do, because what this is effectively doing is it's saying whatever you create in these parentheses here, if you have any kind of exception at the end, I'm going to close out, I'm going to call the close method on the variable that you declare here, no matter what happens. And so no matter whether this code crashes in the middle or whether it executes cleanly, it's always going to get run. And so this is equivalent. Here we go. Here's another version of doing this. I'm just going to go ahead and throw it all at you. This is equivalent to doing the following: declaring scanner, setting up a try block, initializing the scanner, catching the exception that might be thrown at you and saying if in not equal to null, in.close. Let's initialize it. All right, so let's look at what's happening here. We're creating a scanner object. We're setting it equal to null. We begin to run the code in the try block. If at any point in this try block we get an exception because something went wrong, we're going to catch that exception and we're going to manually close our in variable. We're first going to check to make sure it's not null in case for some reason we threw an exception before the constructor was effective, and then we'll close it in that case. This is so heavyweight, and this was happening so often that Java introduced the shorthand notation that I showed you a second ago. So let's put the shorthand notation back because this is what's done professionally now. Instead of doing that, we put the scanner in a try block right there. And then what this does, what the language convention is for this try with parentheses is that we'll close it at the end. All right, so that's a lot. Let's go ahead and run our method now. We're going to be looking at our, let's zoom out. Let's look at our, let's see, I'm not sure you're going to be able to see that. Let's go back and let me lift up my console for you so you can see it. All right, so I had to select the console tab because it wants to show me, desperately wants me to show you Saros. So it says which floor? It's prompting me using my scanner, and I'm going to say floor 10 and hit return. And then it says the elevator is really going to 10. And I know that my program is complete because, how do I know my program is complete? Well, let's run it again to show what happens. Okay, I'm running the program again, and you'll see that while the program is running in the console, this red square is lit up. That means my program is running. That's one way you can tell. And if I wanted to stop it without completing my program, I could hit terminate there. Instead, I'm going to type in a number higher than 10. I'll type in 14 and hit enter. And now it says the elevator is really going to 13 because we ran our if statement. Let's run it one more time. This time, let's not type in an integer and let's see what happens. All right, we get an exception. It breaks, our code breaks, and it crashes as a result. Okay, now what I would like to do is I would like to run this with code coverage. We used code coverage before in order to work through our code when we were doing JUnit testing, but code coverage can be used in other cases as well. I'm going to take that code, that sample code that was used for different versions of our scanner class. I'm going to drop it at the bottom here, just so you have reference to it if you want to explore it a little bit as comments, but I just want to clean up the code up here a little bit. All right, so let's take a look at what happens if I run the main method. Rather than doing run as, I'm going to do coverage as, and coverage as a Java application, and it'll show me which lines actually get executed. All right, if I say I want to go to floor 5 and hit enter, I get code coverage that shows up on my class here, and it shows me which lines of code were run. You can see that the scanner was created on 9. I ran my prompt on line 11. I collected my input on 12. Line 14 doesn't actually have any code associated with it. It's part of the compiler. There's no code generated from 14, so it doesn't get colored. Line 16, it checks to see if requested floor is greater than 13. Now what I typed in on line 12 was 5. And so 16 is coded yellow because in my run of the code, this if statement was reached, but only one of the possible outcomes was explored, the false outcome. And so you can see that in line 19 and 20, 20 is green because I ended up running the false branch. And then you can see 22 was run as well. So now remember what this looks like for a moment. Yellow, red, green. And let's run that as code. Let's do that code coverage again. So click on main, write code to code coverage, Java application. And instead of 5, what I'm going to do is I'm going to type in a number greater than 13, 15. And you can see that the code coverage switched. I still ran 9, 11, 12, got down to 16, ran half the outputs for 16. But in this case, because requested floor was greater than 13, we executed line 17 instead and never executed the false branch. ended up subtracting 1 and printing out the if statement there. Just to reiterate what happened here, we could get rid of these curly brackets, and then the if statement only runs one particular line. So if we don't have the brackets, this will still work. Run code coverage, Java application, floor 20. You can see we ran the true case, and we could run the false case as well. In both the if statement and the else statement, we can put curly brackets or we can not put curly brackets. If we only have one line that we need to run, it's optional. If we have more than one line, it's not optional. To reiterate, the indentation doesn't matter. So here's a version where I've messed up the indentation entirely, and I'll run code coverage again. And I'll type in 5. And you can see we run the false branch. Indentation sure is helpful for me as a programmer to be able to view what my intention is in the code to show that the curly brackets are a smaller scope of code that's being run. But I don't have to do that because Java looks at scoping by using curly brackets rather than using indentation. In Python, indentation was required. In Java, it's optional. If I have messy code or I'm sloppy, I'm the kind of person who leaves cereal bowls under my bed and would like someone to come and clean them up. You are lucky because you do have a maid service in Eclipse, and that exists under source. If you go under source and you click format, Eclipse will go through and it will clean up all your code according to particular kinds of formatting that are built into the preferences if you ever want to change them. One of the things that it does is it indents everything cleanly. It puts an appropriate number of spaces in between different lines in your code, and it makes sure indentation works out well. So that's really great. You can really mess up your code. You can really mess up indentation in a lot of ways, and formatting will fix it all up for you. And that's really good because makes your code look professional, and it makes it a lot easier to visually parse. Mess it up, go under source, format, and it cleans it up for you. Okay, that is a fast and furious introduction to the if statement. The basic structure of the if statement. What I haven't shown you is I haven't shown you the different varieties of conditionals that you can put in your conditional statement, so in the parentheses on the if. And the other thing that I haven't shown you is multiple outcomes. So if statements where you don't just have if else, but you have if this, or if this, or if this, or if this, all those chained together. So we'll take a look at that on Wednesday, and I'll see if you have any questions right now about this code. How are you doing? And to do that, I am going to go off YouTube and we'll go to in-game broadcast. Let's see what you got.
I'm here.
Thank you.
Thank you.
Thank you.
Thank you.
Yes.
Do you have a question, Matthew, or just?
Mr. Patterson?
Yeah, I'm double broadcasting. Stand by.
Yes, I can hear you. Yes, I can hear you. Yes, I can hear you.
Okay, this has been Monday, February 8th, CS30, signing off.